Hello guys, so ito na tayo ulit. So this is continuation nung last video natin regarding sa hydrostatic force on curved surface. So yung previous example natin is a parabolic shape na dam. Okay, so in this case, okay, for example number 2, and by the way, this is from Engineering Fluid Mechanics, 9th edition by Elgar, Williams, and Crow. Okay, so for the curved surface AB, where L is equal to 1 meter, so this is also 1 meter, and meron daw tayong width, okay, so meron tayong width doon na, okay, so 1 meter din. Okay. So determine the magnitude, direction, and line of action of the vertical component of hydrostatic force. Okay, so sa previous example natin and yung discussion last video, so sabi natin is that yung vertical component ng hydrostatic force is equal to the weight ng liquid above, directly above ng gate. But in this example, wala naman tayong liquid, wala naman tayong liquid dito, no, sa portion na to. Okay? Okay. So, kung meron tayong liquid dito, then yung weight nito, which is directed downward, okay, may direction siya ng downward. So, ito yung vertical component ng hydrostatic force. Okay, so applying somewhere dito sa point na to. But in this case na wala nga tayong volume dito, pero still we have yung um, hydrostatic force dito na sa ilalim ng ating gate. Okay, so let's say ito yung ating hydrostatic force F. So, meron tayong force yung ating horizontal component and meron tayong vertical component FV. Okay. So, again, yung force natin shall be, in this case, no, pag circular is perpendicular yung application niya dito sa surface natin. Okay. So, although wala tayong liquid dito sa taas, pero may pressure pa rin tayo dito sa ilalim, which is equal to, again, yung pressure ng hydrostatic force, diba? That is simply equal to gamma unit weight times no depth, height, h. Okay? So, kung meron tayong liquid dito sa taas, so ito yung ating, consider ito yung ating h. Pero, at this point, if we get another point, same level, let's say nandito, okay, so di ba meron din tayong pressure na equal din doon sa unit weight times height, so same depth h, okay, so same pressure tayo dito, then that pressure again is same lang nun nandito sa may gate natin, but ang magiging direction nga lang natin is magiging upward siya, no? Kasi nga yung pressure is nanggagaling sa ilalim. Nanggagaling sa ilalim, so tutulak siya pataas. So kung liquid natin is katulad dito sa previous example natin na nasa ibabaw nitong gate. So of course yung direct weight nito is tutulak dun sa gate pababa. Okay. So let's solve for letter A. So determine the magnitude. Unahin na natin yung magnitude. Okay, so magkakaroon tayo ng uh, uh, imaginary volume of liquid. Okay, so sa mga ganitong cases na nasa ilalim yung pressure natin, no? So magkakaroon tayo dito ng imaginary. So since imaginary to, hindi downward nga yung kanyang direction. Instead, opposite, pataas. Okay, so hatiin natin to sa dalawang shape. Meron tayong square, 1 meter by, dito hanggang dito to. Okay. So, asensya na kayo sa drawing. So, 1 meter, 1 meter, 1 meter din to. Okay. Then, meron tayong quarter of a circle dito. Both have 1 meter na width. So, again, yung hydrostatic force Fv is equal din sa weight ng liquid. So, in this case, again, imaginary lang yung liquid natin above ng gate. Okay? So, this will be equal to, yung weight is unit weight times ng volume. So, dalawa yung volume natin. Unit weight, walang binigay na value ng height ng unit weight ng water, no? So, we will use yung standard na 9.81 kilonewton per cubic meter. So, kailangan natin ng multiply ng volume para makancel tong cubic meter. So, maiwan na unit natin is yung kilonewton. So, volume natin, yung mga area muna. So, yung, let's say this is area 1. This is area 2. Okay, so area 1 is equal to 1 meter by 1 meter. Then, plus yung area ng etong quarter of a circle natin. So, ang area ng circle is pi. Radius natin is 1 meter squared. Okay, so yan yung sa circle. Pero 1/4 nga lang, so over 4. Okay, and then, yung ating width na 1 meter para makakuha tayo ng volume. Okay. So, compute natin. So, we have 9.81 times 1 plus bali pi 1 pa rin naman to, shift pi over 4, then times 1 meter pa rin. So pwede ko nang hindi ilagay dito yung 1. Okay, so we have 17,515. Okay, so this is yung magnitude. Okay, so this is for magnitude. Then direction natin is, upward. Okay. Direction and line of action. Siguro yung line of action, so yung uh, distance natin, yung distance niya, no? So, let's say distance from A na lang. So, let's say nandito nga yung ating hydrostatic force. So, let's call this distance x na lang. Okay. So, we need to solve for the location no vertical component ng hydrostatic force. So, to determine yung centroid, okay? So, yung centroid ng itong vertical component, no? So, meron tayong dalawang area na kinonsider. So, ang centroid nitong square is somewhere dito sa gitna. Okay? Then, dito naman sa quarter of a circle natin. So, let's say somewhere here. Okay. Then, meron tayong distance dito na, okay. So, dito madali lang, no? This is 0.5 meters. So, kalahati lang. But, in this case, sa quarter of a circle natin, so from point A, so ang distance natin dito is, okay, so this is 4r over 3 pi, where yung r natin is 1, so 4 over 3 pi. Okay. So, moment of areas lang tayo, no, about this axis passing through point A. Okay. So, yung ating distance x, siguro X bar or XCP na lang. Center of pressure. CP. Yung ating XCP, multiply nung total area natin. So, ito rin yung total area natin, no? Kanina. Okay. Multiply by 1 plus pi over 4. So, sinimplify ko na lang, no? So, this will be equal to. So, yung area 1 natin is 1 meter by 1 meter. Then, yung moment arm natin or in distance ng centroid ng area na yun is 0.5 meter. Then, plus yung quarter of a circle natin. Area niya is pi 1 squared is 1. So, pi over 4. Then, yung distance natin na 4r over 3 pi. Okay? So, again, this is 1. So, maka-cancel lang yung 4. Cancel yung pi. So, ang matitira is 1/3. Okay? Tama. This is pi over 4 area distance. This is area. This is distance. Okay, so we can now solve for XCP. Adjust lang natin to. Okay. So this is 1 times 0.5 is 0.5 plus 1 over 3, 1/3. Then, ito pwede nating i-transpose, magiging, ano siya, no? Divide. So, divide natin to ng 1 plus pi over 4. Okay. So, we have 0.466 4667 meter. Okay. So, that is yung line of action of the vertical components. So, we have 17.515 kilonewton upwards, okay, with a distance of 0.4667 meter from point A. Okay, so let's continue para sa ating letter B. So, determine the magnitude, direction, and line of action. So, same lang, but in this case, yung horizontal component. Okay. So, magnitude para sa letter B. This is for letter A. So, again, no, kung dito tayo nakatingin, papunta ron, so, makikita natin dito sa side na to is yung parang vertical projection ng gate, which is, this is 1 meter then meron tayong width na 1 meter. So, square yung makikita natin. Okay? Then, yung H bar, this is HCP kasi center of pressure ito. So, kung, again, ipoproject natin yung area. Okay. So, let's say 1 meter by 1 meter ito. So, imagine na lang natin na square siya. So, ito yung ating centroid. So, ito yung distance na H bar. Okay, so from the centroid ng area. Okay, so solving for FH. So, formula natin dyan, hydrostatic force, parang plane surface na lang. So, imaginary vertical plane is, okay, gamma h bar A. Okay, so we have 9.81 kilonewton per cubic meter multiplied by, so 1.5. Then area natin, area nito, area ng gate, vertical projection, okay, is 1 meter by 1 meter. Okay, so we have 9.81 times 1.5, then times 1. Okay, so we have 14.715 kilonewton. Okay, so this is the magnitude. So what about yung direction? So to the left. Okay, and ano yung line of action? Okay, so ang kinahanap natin is yung distance from the bottom of the gate. Okay. So hindi naman sinabi kung ano yung reference natin, no? So dito na tayo sa bottom ng gate. So ito yung hinahanap nating distance, distance y. So distance y na lang. Okay. So paano natin kukunin yan? Again, pwedeng kung ito yung centroid, ito yung center of gravity, ito yung CP, meron tayong distance E. So may formula tayo dyan na E is equal to ICG, moment of inertia about the center of gravity over area y bar. Pero kung idiretso natin dito sa HCP or kung itong YCP from liquid surface papunta doon sa may CP. So, vertical distance yung YCP natin, no, since yung kino-consider natin plane is vertical din. Okay? So, sa plane surface kasi kung naka-incline yung surface na kino-consider natin, so yung distance Y is along doon sa plane natin, along doon sa plane. Okay? So, from liquid surface, along the plane, papunta doon sa may center of pressure. Okay, but in this case na vertical projection nga yung ginagamit natin. So we have a vertical plane. So yung YCP is same lang nung HCP. Okay, so HCP is equal to moment of inertia about the liquid surface over area y bar. Okay, so ano yung moment of inertia from the liquid surface? So double moment of area lang naman yan, no? About this axis. Okay, so area 1 by 1, then 1.5 squared. So yun yung moment of inertia natin. Okay, so yung kalahati, okay, so this is 1 meter. So this is, yung distance na to is 0.5. So kung i-minus natin yung distance E sa 0.5, so makukuha natin tong distance Y. So ito na lang yung gamitin natin. Okay, so for distance E, so ICG, so rectangular or square, B is 1 meter, H height nung area is 1 meter din, BH cube over 12, area is 1 meter by 1 meter. Okay, so BH cube over 12, then area, and then yung ating Y bar. Okay, okay, so Y bar is 1.5. So hanggang Y bar siya, no? Y bar. So it's meaning from the centroid, from liquid surface to the centroid. Times 1.5. Okay? So pwedeng magiging ano na lang to? 1 over 12 times 1.5. 12 times 1.5. Okay? So we have This is 5.55 times 10 negative 2 or 0.055 meter. Okay, so 556. Okay, so this is 4 decimal places kasi, so gawin ko rin itong 4 decimal places. Okay, so 0.0556 meter. That is distance, ipangalan pala. So yung hinahanap natin na y, distance y, is equal to 0.5 minus 0.0556. Okay. So buuin ko na lang yung sagot. Okay. So distance y is 0.4444. Okay. So nakuha na natin yung magnitude, direction, and yung line of action. Okay, so for letter C, determine the resultant hydrostatic force acting on the surface. Okay, so madali na lang to, no? So for letter C, yung total hydrostatic force is simply the square root of okay, so 17.515 kilonewton squared plus 14.715 kilonewton squared. Okay, and we will get square root of 17.515 squared plus 14.715 squared. Okay, so 22.876 kilonewton. So that is the total hydrostatic force. So hindi naman tinanong yung direction, pero dadaan nga ba yung total hydrostatic force natin dun sa center nitong quarter of a circle natin. Okay, so dadaan ba siya dun sa point na yon? So check natin. So meron tayong triangle dito. So nakuha natin tong distance na to na XCP 0.4667. Okay. And then etong portion na to, so this is 0.4444 meter. Okay. So makukuha natin tong height na to. So this is 1 minus 0.4444. Okay. Okay. So meron na tayong triangle. So kung kunin natin yung angle theta based dito sa dalawa na to, okay? So that should be the same angle nung nandito. Okay, using yung mga forces natin, yung FV and yung FH. Okay? So, or pwede rin tayong mag ratio and proportion. Okay? So, pwedeng ratio and proportion din, no? Okay? So, opposite over adjacent is equal din since same angle sila. So, that should be equal to the opposite over the adjacent side nitong kabilang triangle. So, unahin muna natin yung dito sa ano natin, no, sa left side, okay, sa mga distance. So unahin ko yung opposite ng 0.5556 divided by yung adjacent side is 0.4667. Okay. So, ito yung nakuha nating ratio. So, sa kabilang side naman, ang opposite natin is yung vertical, FV. FV natin, 17.515 divided by yung adjacent ng triangle, adjacent side ng triangle, FH. Yung FH natin is 14.715. Okay. Sa mata natin, 1.1904, 1.1902. Okay. So, nagkaroon lang ng counting discrepancy dahil this is 5 significant figures. Ito naman is 4 significant figures lang yung mga distances natin. Okay? So, we expect na hanggang 4 significant figures lang tayo magiging accurate dun sa result, which is 1, 2, 3, 4. So, 1.190. Okay? So, that proves na yung total hydrostatic force will pass through the center of the circle. So, kaya meron tayong laboratory na na okay. Kaya lang walang makakapag-laboratory sa panahon ngayon dahil nga sa quarantine. Okay, so siguro nakita nyo, kung mararecall nyo sa mga nakapag-take na ng fluid mechanics, meron dong quarter of a circle na apparatus, parang ganyan. Okay. So, nandito yung center niya. So, itong point na to, ito rin yung pivot ng, so meron tong isa pang, okay, so meron siyang, of course, parang rod kung saan siya nakakonect. Then, merong counterweight dito. Okay, so para ma-balance mo siya. Okay. So, kapag naka-balance na yan, kasi ito yung yung container. Then, kapag nilagyan mo siya ng liquid, so yung liquid dito sa part na to, okay? So, circular to, no? So, lahat ng mga forces na yan will pass through the pivot or pivot. Okay? So, ano lang yung may iwan? So, yung kanyang hydrostatic force dito sa may vertical surface ng apparatus. Okay? So, kung tinaas mo pa yung tubig hanggang dito, so yung mga forces dito sa portion na to is dadaan pa rin dun sa pivot na hindi siya magkakos ng moment or turning moment dito sa apparatus. So, ang magiging ano na lang dyan is ang magkokontra na lang dyan is itong hydrostatic force dito sa vertical surface and yung may mga weights pang inilalagay dito. Okay? Ayan, so maganda rin tong experiment na to. Okay, so that is for today's video. So we will have another example. So putulin ko na lang na para hindi masyado mahaba. So we will have another example. So pakita ko na. So ito yung next example natin. Okay, for the next video. Okay, so again, if you like this video, please consider to subscribe and share nyo sa mga classmates nyo or sa mga kapwa nyo mga nagre-review. Okay, so habang lalo ngayong panahon ng pandemic. Okay, so kung estudyante pa, so share nyo sa mga classmates nyo. So sana makatulong kahit papano. And kung meron kayong mga gustong problems na i-solve natin dito sa YouTube, so just comment lang or paki-like na lang po yung yung Facebook page ko. It is Civil Engineering Online Tutor. Okay, so lagay ko na lang din sa description yung link. Okay, so that's it for today. So God bless and ingat tayong lahat.